Okay, first a quick review about what even and odd functions are in general, not trigonometric functions, not yet. An even function, I'll start by giving you an example. Your textbook uses the same example. Function y equals x squared is an even function because when you plug in 2, you get 4. And when you plug in negative 2, you also get 4. So plugging in the negative version of the x value gives you the same answer as if you plugged in the positive version of the x value. These two values are equal. This is called an even function. Let me move this piece down here. Here's an odd function. This is x cubed. I'm not very good at drawing these, but bear with me. I'm going to try that again. There, that's a little bit better. Here, when you plug in 2, you get 8. When you plug in negative 2, you get negative 8. Okay, we're plugging in negative 2. So here, when I plug in the negative version of the x value, in this case, here I was plugging in 2. When I plug in the negative version of that x value, what I get out is not just the same value as I would get if I plugged in the positive version of the x value, but the same number but negative, opposite. So if I plug in the negative, where's my pen? If I plug in negative 2, I get not just, let me see, can I hide this a little bit? Hide that. I don't just get the same value as if I plugged in the positive version of negative 2. I get the same number, but its sign is the opposite. Okay, so this is what we call an odd function. So we're going to keep these two ideas in mind as we go forward. I think this is going to make a lot more sense once we've learned how to graph sine and cosine. We're not quite there yet, so this didn't work very well, did it? Try moving. There we go. I'll go grab my negative sign. Apparently I'm taking the box with it. I wasn't going to bother with the box, but there you go. All right, so this is going to make a lot more sense when we can graph sine and cosine. So I'm going to come back and visit it when we get there. But because your book introduces it here, I'm just going to spend a moment and kind of give you an idea what your book is talking about. Before I do that, though, I'm going to replace the x in this notation with some other variable. In fact, I think I'll use t, which hopefully will make sense in a minute here. So I'm going to use t as my input value. For one thing, I want to say that if I use t as an input value, hopefully that suggests to you now that I'm inputting a function, that I'm inputting an angle into a function like sine or cosine. Okay, that's kind of what I'm trying to get at here. But all I've done is change the variable's name from x to t. I've done that for a couple of reasons. One is that t is the variable we're using as function values, input values. That's the name of our angle. But also x equals cosine of theta, or x equals cosine of t. So if x represents cosine, then plugging in x here doesn't make sense. So I've just changed it to clarify things as we go along. Now what I'm going to do is I'm going to give myself a unit circle with some axes. And I'm going to grab an angle, just kind of any old angle here. Then I'm going to reflect that angle into quadrant 4. That's not quite right. Let's try that again. There we go. So now I have two angles, one above the x-axis and one that's the same size below the x-axis. Both of these have x, y coordinates, remembering that x is cosine of t, y is sine of t. Okay, but the coordinates are going to be the same for x, right? For both of these angles here, for both of these coordinates, for both of these points, the x coordinate is going to be the same. I can go out this far and then up, or I can go out this far and then down. So x is exactly the same value. Y, on the other hand, because they're the same angle here and here, is going to have the same magnitude, the same size. I'm going to get this far out on the x-axis and then go up Here I'm going to get this far out on the x-axis and then go down the same distance. But because I'm going down, I'm going to label it negative y. Now, this angle here is angle t, and this angle here is technically negative t because I've taken the same size of angle, but I've gone in the clockwise direction instead of going in the counterclockwise direction. So whatever size this angle is the same size, but we call it negative t because it's going in the opposite direction. It's going in the clockwise direction. So now let's take a look at these formulas up here. For angle t, you see the right-hand side of this function here is just f of t. If I plug in a t, plug in angle t, what do I get? X comma y. I get cosine comma sine. They're both positive, right? If I instead plug in a negative t, what happens? If I instead plug in a negative t, the x is the same, which is cosine, right? The x is the same, cosine is the same, so plugging in a negative t for cosine gives me the same as if I plugged in a positive t. That means that cosine is an even function. If I plug in a positive t or a negative t into sine, well, when I plug in positive t, I get just y, but when I plug in negative t, I get negative y. So if I plug in a negative t, negative angle, if I plug in a negative t, I don't just get sine, I get the opposite of sine. So that means that sine is an odd function. That's really all I want to do with this at this point. In case you happen to need it, I'm going to let you know that since cosine is even, so is secant. Remember, that's its reciprocal cousin. Cosine and secant are just reciprocals of each other. Secant is defined as 1 over cosine. Since sine is odd, so is cosecant. And, did I spell that right? Cosecant, yes. And as it happens, so are tangent and cotangent. These are all odd functions. And that's all I'm going to deal with this for right now. I hope to come back to this when we're talking about graphing functions, but that's enough of odd and even functions for just now.